So hey guys, welcome back to DevOps HQ. In our last tutorial, we have seen that how we can use a startup script for configuring our web servers. But still using startup script, it didn't fulfill our requirement. So earlier our requirements are that first we need to provision the virtual machine, means we have to launch the virtual machines, and second we have to configure all those virtual machines, like we have to configure our web server on those new virtual machines. So using a startup script, now we don't have to configure those virtual machines, like we don't have to configure our web server, but still we have to provision our virtual machines. So the provisioning process is still manual, like it's not automated using a startup script. Now to solve that challenges and to solve those use cases, we will learn about some new things, and those things will help us in resolving our issues. So in this video, we will learn about instance group, instance template, and load balancing. So let's get started. So this will be our architecture diagram for today. So here we can see that this is our startup script, and using that startup script, we will create our instance template. So what is an instance template? So instance template is nothing but it's still a kind of a script which we will use to store the configurations of our virtual machines. So the informations like which type of virtual machine, like it's Ubuntu or it's Windows or any other operating system. So we will store that information in that, and also we can configure that how much amount of RAM and how much amount of hard disk or SSD which we're gonna use by this virtual machine, the network configurations, the firewall, and what commands it has to run, like when the instance came into the running state. So all these informations which is related to the virtual machine, all those informations are present inside this instance template. And using this instance template, we can create multiple similar web servers or multiple similar virtual machines, and we don't have to do anything on that. And all those things has been taken care by this instance group. So this instance group will use this instance template to create the virtual machines. And also it resolves our second challenge, that is of auto scaling. So now let's suppose if you want to do auto scaling, which means during the time, like during the peak hours of your business, you want more number of instances, and during the night time when the load is very less, you want to reduce your virtual machines. So all those things has been taken care by this instance group. So this instance group will use our instance template which we have provided, and using that instance template, if we need multiple new servers, then on our behalf this instance group will create all those servers depending upon the requirement which we have given. So let's suppose if we want that when our CPU utilization will reach to 60% or 75%, then we want to launch or create new virtual machines. Also we can configure on based off other factors like memory or disk utilization. So depending upon our requirement or use cases, this instance template will increase or decrease the number of virtual machines. And again, like when we have multiple number of virtual machines and when we have multiple instances, we can't like remember all those IPs, and we can't individually provide IPs of those things to our end users, because let's suppose it might be happen that the instance which was running in the morning, it has been terminated because the load which we have in the morning has been reduced now. So now that instance will not be a part of our instance group. So for that we will use load balancer. So what this load balancer will do, that it will take the request from our end user, from the users, and it will redirect those traffic to the servers in the instance group which are in healthy state, and whatever output it gets from our instance group, it will revert to the end users. So this is how our architecture will look like, which we're gonna implement on AWS and GCP. So let's start with the tutorial. So first we will deploy on GCP. So let's go to our console, and here like let's go to the compute, and in the left hand side we will see there is an option of instance template. So let's choose this, and here we need to create an instance template. So I will name this template as web server template, and region, like depending upon your use case, you can choose regional or global. Here for our tutorial, I will go with regional and Mumbai. Then this is the instance type, like what kind of machine you need. So here if you configure, let's suppose E2 micro or E2 small, then all of those instances which will be provisioned by our instance group will be of same type. So that you can select here. So for this tutorial I am choosing E2 medium, and for boot disk let's change it to Ubuntu, and I want to allow, let it be default only, and allow the HTTP and HTTPS traffic, and the same configuration like whatever we have done for our this instance template, it will remain same for all of our virtual machines which will be provisioned by our instance group. So now let's click on this advanced option, and inside the management part we have to paste our startup script which we have created in our last video. So let's copy it here and paste it, and then we can simply create on create button. So our instance template is created, and now we have to create our instance group. So for that we have to scroll a bit, and here we will find this instance group. So just click on this instance group and click on create instance groups. So I will name it as web server instance group, and in this instance template I will choose this web server template which we have just created now, and I will go with single zone. If you require that your instances will create into different zones, then you can select multiple zones, and here you can select the zones, whatever zones you want. So just click on OK, and let's go with multiple zones now. Now comes to auto scaling. So here, like as I mentioned that we have to define the minimum and maximum number of instances. So during like peak time, how much number of instances it will maximum create, and during non-peak time, like when we have very less number of nodes, then how much instances should be there to handle those loads. So for this tutorial I am giving the minimum number of instances to 3, but you can give it according to your use case. And for maximum number of instances I will give it to 5, such that my maximum number of instances won't cross the limit of 5. And here the CPU utilization, so I will change it to 70%. Click on done, and I think we are good with other things. Here there is one more thing, that is of health check. So I am not creating a health check now. I will create this health check while creating the load balancer. So just click on create here. So our instance group is creating, and it will provision 3 virtual machines on our behalf. So if I go to this virtual instances, so here we don't have any instances as of now, but yeah, you can see that we have 3 virtual machines in provisioning state. So it will be come into the running state in some time, and these instances are being managed through this instance group. So let's suppose if I go here in this virtual machine, and if I delete 1 or 2 instances, then another new instances will be provisioned by this instance group. So that is the benefit of using instance group. Here, like in this case, we don't have to manually manage our virtual machines. It has been managed through our instance group. So if anything, like in future, if let's suppose any migration or any downtime or anything has been happened to our virtual machines, then we don't have to worry about this, because on our behalf instance group was there, and he will create the instances or provision the instances. So until our virtual machines are coming into running state, let's create a load balancer. So here search for load balancer. Let's go with load balancing and click here on the top that create load balancer. So for this tutorial I will go with application load balancer. So click on next, and I will go with public facing external load balancer, such that we will get a load balancer IP which I can share to my end users. Then click on next, then next, then again click on next and create on configure. So let's name our load balancer as web server load balancer. For front end, let's click on done here, and backend we have to configure our backend. So let's click on create a backend service. So I will name it as web server backend. and instance group, it should be web server instance group, port number. So in our case that we are using Apache 2, which will by default running on port number 80. Enable and here health check. So we have to create a health check. So this health check will help us in determining that which instance is healthy and which is not, such that all our requests will go to the healthy instance only. So just click on create a health check and name it as web server health check, and our protocol should be HTTP, and click on save here. So create our backend server and then click on OK. So our backend services is created, and now just review and finalize this. So just click on create here. So here we can see that our access type is external, which means that our load balancer IP, so it should be accessible by publicly. Now let's check that our VM instances came into the running state or not. So here we can see that our virtual machine is provisioned. Now let's copy any of this IP and try to. So here we can see that our web server is coming, which means that in all these instances our web server has been configured successfully. And now let's wait for the load balancer to come into the running state, such that we don't have to open it through each of these IPs. We can directly open it through the load balancer IP, and all these three web servers will be accessible through our load balancer only. So now let's check that if it came into the running state or not. So it's still in provisioning state. So here we can see that this is our IP of our load balancer. So using this IP address, we can access all of our backend servers. And also, in case if you have your own domain, then you can map this IP to your domain, such that when any person or when anyone hit it to your domain, then this web server will be appear. So now if I try to open this, I don't think that it should work now, because we are still in provisioning state, but let's try. Let's wait. Generally, provisioning of load balancer will take time, and it takes around 5 minutes. Yeah. So I think it came into the running state, and after that also, like, it will take some more time, such that this URL will start working. So we have to wait for some more time. Yes. So now it's working. So here you can see that our web page is coming here, and let's close these two tabs. And now let's refresh this. And now we can see that our public and private IP is changing here. So we can see that we have 3 public and private IPs. And if our load increases, like if we transfer some more load to this web server, then it will increase the number of instances from 3 to 4 or 5. So we are done with the GCP now. Now let's see that how we can do the same configuration over AWS. So let's go to our AWS console and let's go to the EC2 dashboard. Here we can see that this is our launch template. So click on this launch template. So on AWS, instance template is known as launch template. So please don't confuse with the name. They almost have the same functionality, just its names are different. So here just click on create launch template, and I will name it as web server template. And here we have to choose the Amazon Linux. So click on browse more AMIs. Then we will go with Amazon Linux free tier eligible. So this one is eligible for free tier. So just select it. Then instance type. So we will go with T2 micro. Then we have to choose a key pair. And then network setting. So I don't create a network setting. I will use the already created network groups. So I believe that it will be used in our last practical. So it has the HTTP and HTTPS traffic enabled by default. And now for ABS volume, so let it be default, and expand this advanced tab, go to down, and here we have to paste our script. So let's copy it from here and paste it, and then click on this create launch template. So we have created our instance template or the launch template, and now we have to create our instance group. So in AWS, the instance groups are known as auto scaling groups. So just scroll your left hand side and you will find auto scaling groups at the bottom. So just click on this auto scaling group and click on this create auto scaling group. So here we have to give a name. So just name it as web server auto scaling group. And then we have to select a launch template. So I will choose this web server template which we have just created now, and then click on next. I will go with the default VPC which we have, and here we have to select the zones. So let's select all these zones such that we will ensure the maximum availability. And this is because such that, let's suppose in future if any natural disaster or any problem came into one of the data center, and all the machines which are present inside that data center is not being able to come into the running state or not being able to perform as we want. So in those cases as well, because we have our backup servers in different regions. So here we can see that there is a warning that the instance type which I have selected, that is T2 micro, is not available in one of the availability zone. I'm not sure that in which it's not available, so let's delete the last one. So I think it was not there in that, and so now let's click on this next, and now it will ask for the load balancing. So on AWS we don't have to explicitly create a load balancer, because while creating the auto scaling group it will automatically offer the load balancing. So here in this case we have three options, that is no load balancer, attach an existing load balancer, but I don't have any existing load balancer. So for the third one, that is attached to a new load balancer. So we'll go with this attached to a new load balancer, because we have to create a new load balancer. Then it should be of type application load balancer. Yes, I want it as internet facing. I won't go with internal. Otherwise, my end users, like the users which are not part of my VPC, they won't be able to connect to our web server. So that's why I'm choosing public facing, such that even the users which lies outside of my VPC and my configuration, those also can access our load balancer. VPC, I think we are good with this. So listening and routing, here the protocol should be HTTP port 80 and default routing. So we have to create a target group. So click on this create a target group, and it will automatically fetch the name of our target group, that is web server auto scaling group 1. And then VPC letters, so I will go with no, because I don't have any letters to attach, and I will turn on this load balancing, and I think we are good. Just click on next. Desired capacity, so I want that 3 instances should be there. The minimum should be 3 and maximum it will go to 5. And then automatic scaling, so I will choose target scaling, and the value I will change it to 70. So it basically, so what this target value will do, that whenever our load increases from 70%, that our CPU utilization will increases from 70%, then it will provision a new instance. And then instance warm up. So I believe that our virtual machine will be able to run all these commands within 60 seconds, and it will come into the running state. So that's why I put it here 60 seconds. And then the maintenance policy, so I will go with no policy, because I don't want any as of now. And then click on next, and here again click on next, then add tag. So I will tag it as web server, and here I will tag as auto scaling. Then click on next. So I think we are good with this. Then click on create auto scaling group. So this will create our auto scaling group, and also it will create a load balancer for us. So if I can go to the menu, and here if I can open this load balancer in a new tab, then we can see that our load balancer is also getting created. So this is our instance group, and if we go to this instances, number of instances, then we can see that these are the instances which are in running state. So these three instances has been created by our launch instance template as a part of our auto scaling group, and these instances will be used when we hit our load balancer IP. So if we go inside this load balancer IP, then this is our DNS name. So when we hit to this URL, then our traffic will get routed to these instances in backend. And there is a new feature which is resource map. So if we click on this tab, then we can see the entire flow of this. So this is our listener, that is HTTP port number 80, and this is the target group which we have created, and this target group will it sends our request to these instances which has been provisioned through our launch template. So let's refresh this. So now let's try to connect to our web server using the public IP address. Yes. So our web server is configured. Here we can see that our web page is coming. Now let's try for another IP. Yes, it's also coming. So now let's wait for our load balancer. Okay, so it's completed now, but I think that still it will take some more time to come into the running state. Okay, it's working. So now here we can see that this is our private IP and this will be our public IP of the server from which this web page is coming. So now let's try to refresh this. Yes, so we have three different public and private IPs. So congratulations, we have successfully configured our load balancers on AWS and GCP using instance template, and now we don't have to worry about the provisioning and configuring our web server. So if anything will happen in future, then it all has been taken by this instance group and this load balancer. Now we don't have to worry about the auto scaling or auto healing kind of thing. If any of our web server will goes down, then our instance group will automatically create a new virtual machine and configure the web server on our behalf. And also if our load increases, then also we don't have to worry, because the instance group again launch new instances, and if in our web server load is very less, then this instance group will reduce the number of instances and it will delete some virtual machines from our instance group, and it will came into the minimum number, that is 3 in our case. So I hope you enjoyed this video, and thank you so much for watching.